Hey everyone, this is Bradley Bush with another algebra video for you. Today our topic is inverse functions. Specifically dealing with inverse functions, we'll tell you give you a review, help you see the big picture, talk to you a little bit about the notation, and then the meat of this video is how do you actually find an inverse? Say you're given a function, how do you find the inverse of that function? So let's start. What is an inverse function? So let's gain some intuition about what happens in the world of inverse functions. So if you take a function is kind of like a machine, right? You have an input, which is generally x. You put something in, an x value in, like 10. You put a value into the function. The function does something to your input, kind of like in a step-like process, step-by-step sequential process, does something to it, kind of like an assembly line. Something starts on an assembly line, and at each stage in the assembly line, something happens to it, and at the end, you've got some finished product. So at the end, your function spits out something after it's done all of these step-by-step processes. So the first thing that happens to your input here, say you've got a function f, and you have an input, which is x. The first thing that happens to your input x is it's multiplied by 3. So whatever you plug in, the first thing that's going to happen to it is it's going to be multiplied by 3. What about the second thing? After it's multiplied by 3, then you can see that you add 2 to it. And then your process is done. There are 2 steps in this process. So this function isn't a complex machine. It only has 2 stages in its assembly line, but it's okay. So if you have an inverse function for f, that inverse function will undo what has been done in f to the input in the reverse order. Kind of like those ultimate fail compilations where you have someone fall and then all of a sudden the tape rewinds really quickly and you see them kind of moving backwards in time. That's kind of what happens with this process. So the last thing that was done in our assembly line we call f and our function was we added 2, right? So if we're adding 2 as the last thing and the inverse wants to undo what was done here when, well, what is done? We subtract 2. If we added 2 as the last thing, well, the opposite of adding is subtracting. So we're going to subtract 2. That's what we do right here. First thing that happens to our input, we subtract 2. So the last thing that was done in our original function was we added 2. What was the second to last thing? Well, we multiplied by 3. That was the step just before that. So what's the opposite of multiplying by 3? Well, that's dividing by 3. So that's what we do here. Divide by 3. The next step in our process is divide by 3. So you can see that we have a step-by-step process in our function. The inverse, so you're going down here, the inverse goes in the opposite direction and undoes everything that was done in the reverse order. So just as a review, if g is your inverse, then it undoes what was done by f in the reverse order. Some function notation is kind of important to have here because it's kind of unique. Here we have something that you don't see a lot. We use an exponent for a different reason. It's not really an exponent. It looks like an exponent, but it's not an exponent. In function notation, this is just a label. This superscript here, this -1, it's just a label that means the inverse of the function f. So this function has a name, f, just like anything else. But if you ever see a -1 up top, that means it's just the inverse. It's not an exponent. That's super important. That's confusing to students a lot. So how do we find f inverse? And again, this is how you write f inverse, f to the -1 of x. How do you find f inverse of x? Well, here are your steps. The four simple steps that we're going to follow. The first one is you replace f of x with y. So we're back to our equation of a line. Then you swap the x and the y, and then you solve for y. And lastly, you replace that y with your inverse notation, f of inverse. And you're done. So let's do an example. All right, so the first thing we want to do is we want to take our function f, which I'm just going to copy and paste. We take f and we replace f of x with y. So we're going to erase f of x and we're going to plug in y. The second thing we do is we're swapping our x and our y. So if we copy and paste again, we're going to swap. So we're going to take x here, and we're going to move it over here. I'm going to take y, and I'm going to move it over here. So literally all we did was we swapped our x and our y. And now we solve for x. Sorry, we solve for y. So if we start out with this, x equals 3, y minus 2, we want to solve for y. Well, we're going to need to subtract 2 from both sides. So now we have x minus 2, and we have 3y on the right. We'll need to divide by 3 on both sides, and that gives us y equals x minus 2 divided by 3. You can also put that put y on the left if you want. So I'm going to do that right here. So we have y equals x minus 2 divided by 3. So step 4 says replace y with f of x. So instead of having a y here, we're going to have f of x, f inverse x, excuse me. And there we go. We're done. We can see that f inverse of x is x minus 2 over 3, and that's the inverse of the original function f, which was 3x plus 2. That's it. Hope this helps. Let me know if you have any questions.